All right, so we're pretty much going to spend the rest of the time talking about these repeating patterns of a solid. And we call the simplest um, repeating unit of a solid a unit cell. So unit cell is the simplest repeating unit of a solid. And once you know this, then you know the rest of the solid. And there are a ton of different types of unit cells. We are just going to focus on the three simplest. And your textbook goes into a whole lot more. I'm not going to go into it. I'm just going to focus on the three simplest. And these three units, or the simplest ones we're going to look at, form what are called cubic cells, which, as the name implies, are based off of cubes. So would be kind of important to know how to draw a cube. So one of the simplest ways to do that is draw a square, draw another offset square, and then connect the corners. We're going to be doing this a lot in the next few videos, so kind of practice that. Um, and so let's go to our first type of cubic cell, and that is the simple cubic. And this is just simply a cube with one atom at each corner. Now, with these three types of cubic cells, there's going to be some information that you're just going to need to memorize and know about them in order to characterize them. So if I were to describe a cubic cell, you should be able to put it into one of these three categories. So I'll draw it and then I'll show you the picture here. So let's draw a cube, and then at each corner is going to go an atom. Okay. Now, even though I've drawn 8 atoms there, that doesn't necessarily mean this cube holds a total of 8 atoms, because all we're going to really focus on is the part of the atom that is actually inside the cube. And that's actually a very small part compared to the whole atom there. So the first important thing to know about a simple cubic is that the number of atoms per cell is 8 times 1 over 8. Because there's 8 atoms there. If you look at the red spheres, there's 8 of them, but only about an eighth of them occupies the inside of the cube. And so in that whole simple cube there, it really only adds up to 1 atom per cell, right? Because only 1/8 of each atom is in the cell. Now, another important property to know is the edge length. So that's this here. And the edge length for a simple cubic is 2 times r, where r is the radius of the atoms involved. A simple cubic cell is known to have what is called the smallest packing efficiency, meaning it's just a fancy phrase, meaning there's a lot of empty space. I mean, if you look at that, like there's a ton of space inside of that cube that's not occupied by an atom. And the other important thing to note is something called the coordination number. This is the number of atoms each atom is touching. So let me bring down a diagram to kind of demonstrate this. So what I want you to do is look at this, actually this atom right here. Okay, well, how many atoms is it touching? Well, it's touching this one here. I'll say, use a different color here. One, and then it's touching this atom, two, and this atom, three. But remember that these are repeating units. So it's also touching this one, four, and it's also touching this one, five, and it's also touching this one, six. So the coordination number for any atom in a simple cube is six. So again, these things that I kind of put stars next to, that's just stuff to memorize, to know the properties of this simple cubic cell. And you're going to have to do this for the other two as well. And as I said, I'll list them out and kind of demonstrate that.